Okay, hello guys, so today we're going to solve a problem and let's see what problem we want to solve today. Search for a problem here. So actually if you can see that you can try to solve problem in here like LeetCode, and then you can like explore, and then you can see for the problem solved also. Let's see what we want to discuss for today. Okay, I think let's start from the easy one. Let's try this two songs. Yeah, we're going to solve this problem. Okay, first of all we're going to read the problem first. Okay, given an array of an integer nouns and an integer target, so return indices of the two numbers such that they add up to target. So you may assume that each input would have exactly one solution, and you may not use the same element twice. Okay, so the problem is about we have an array of integers, and then we have a integer which is target, and we want to search two numbers that is, if we add the two numbers, it's going to be the target. Okay, so that's the problem. Like write this, if you see that 2, 7, 11, 15, and then the target is 9, and then you can just output 0 and 1 because the index of the 2 and 7, which 2 plus 7 is equal 9. This one also target 6, so 2 plus 4. Okay, and then the number of the nums length is 10 power 4. Okay, and number is from negative 10 power 9 until 10 power 9. Okay, and then the target is the same. Okay, only one valid answer exists in this question. So the idea is we can just do like A, and we have a plus B is equal like for equal target, right? That's right. And if we have dA, then we can know that B is equal to target minus A. If we take an index as A, is there any index that is equal to B? Okay, so we can just iterate all of them. So it's going to be, the complexity going to be O(n) squared, because we iterate all of the possibility that we have. So we already get the idea of the problem, which is we have to iterate all of the possibility. Okay, so we can just code it right away. Let's just code it. Then we have the vectors of integers, which is in nums. So we want to look at the size first. Okay, now we can just do the nums dot size. Okay, and then we have to iterate all of it. Okay, so we will do the looping from 0 to size, and this is the pair, the other one, which is we're going to be like from, because they say that you may not use the same element twice, so we're going to start from I plus 1, and which is 2. Oh, I'm sorry, this is J. and then j plus plus. So we already have the pair, which is this I write the comment here, which is I and j. So we can just see if nums I plus nums j is equal to target. Okay, is equal to target. We have to look that that is the answer. Okay, so we're just making the factor. Wait, they say that only one valid answer, so okay, exactly one, so there must be an answer. You can just say ants and then dot push back. You can push to the factor, push back I, and then you can unstop push back j. Okay, so we already got the coding, which we have to return answer, and we're done. Oh, we'll try by running it first. Is it can run or not? Okay, I think we forgot to wait, error non return value. Okay, maybe we'll just return we're just making the ants is here, I guess, so right here, so we can just return the answer, and we'll try to run the code again. Okay, this is accepted, but we'll see if we submit it, is it still accepted or not. We'll see. Okay, this is accepted. So right now we have a follow-up question, which is, can you come up with an algorithm that is less than O n square time complexity? So let's see, can we make this more fast or no? Okay, right now we want to discuss how to make this complexity is less than O n square. So if we already know that, if we know the value of A, if we have the value of A, we can get the value of B, which is the target minus A, right? That's right. Okay, if we know this, so every time we just iterate it from the first index, we can just ask whether they have that value or not. Okay, so we can just ask them, like, do you have the value or not? Okay, so we can just mapping it, we can just use map, which we know that when we have to access a map, the complexity is actually going to more like O log n. Okay, so a map has a complexity for insert and searching is a log n. So you can just use map, so the complexity going to be O and log n. So it's going to be less than O n squared. So let's just straight to the solution. So we want to code it right away. We can code it like we just update this part, right? So first of all, we want to put it in a map first. So we're going to iterate all of it. We're going to use map. We just map nums of b is equal to, we just write the index, and okay, we already write the index, and then we just search integer b is equal to target minus nums of I, right? So we will search if mp map, the map, are they having dot, we're just fine, are they having the value of b. If it's equal to map dot n, then it means that they cannot find b. But if they are not, so they can find b. But let's see, if mpb is equal to I, then we just continue. But if not, we can just answer dot push back I, and then we can just dot push back the mpb. Okay, and then we can just return as. Okay, we can do this, like, let's see if this is can run or no. Compiler error. Oh yeah, we forgot to initialize the map, so we're going to integer and integer and b. Wait, oh yeah, typo, bruh. Let's see. Okay, this one also accepted. So we'll just try to submit it. So let's see, is it accepted or no? We'll see. Bro, it's accepted with complexity on log n. So I think that's all for today's problem. We already solved one problem today, which we can optimize that from on squared to on log n. And that's how the process of thinking how to optimize that. See you guys in the next video. We're going to solve another problems, of course. And then yeah, see you guys, bye bye.